Good afternoon, guys.
Good afternoon, sir.
Good afternoon, sir.
Let us wait for one more minute. Then I will be starting the lecture. If you feel that some noise is there, then you can always ask me so that I will take care of the sources. Okay. So, can you see the slides?
Yes, sir.
Okay. So, let us now start the lecture. Last lecture we have seen that we started with the types of kinematic pairs. Okay. And using different criterias, okay, kinematic pairs are classified in different categories. So we have seen based on the relative motion that what kind of motion is taking place between the two kinematic links which are in contact with each other. So based on that, we classified as sliding pair, turning pair, rolling pair, screw pair, and spherical pair. Then we went on and classified the kinematic pairs based on the type of contact between the elements. Okay, so accordingly, there are these two types, lower pairs and higher pair. In lower pair, you know that there is surface contact between two elements. Okay, their surface will rub with each other while they will transmit the motion. Okay. In case of higher pair, there will be only line or point contact. So examples of higher pairs are friction disc, tooth gearing, gears, belt and rope drives, ball and roller bearings, etc. Okay, so till this classification we have seen in last lecture. Okay, now you see the third classification. On what it is based, that how you are connecting two mechanical elements with each other to form a kinematic pair. Okay, so when a pair is called a self-closed pair, when the two elements of a pair are connected together mechanically in such a way that only required kind of relative motion is possible. Okay, for example, if you expect the links to only turn with respect to each other, means you want to form a turning pair, or it is which is also known as rotating pair. Okay, so only rotating motion is possible. Okay, how you will do that? Okay, how, what do you mean by mechanical connection? Okay, so say suppose if it is one link like this, it is one link and it is another link, and suppose I want to connect it at this point. So what I will do, I will use some sort of pin which I will pass through the holes of these two links, right? Okay, so I will connect them with the help of one pin. That's why it is also called as pin joint. Okay, one pin will be joining this, and at the end of this pin I will close the connection with the help of, say, nut. I can use nut, or I can use some another mechanical element. Okay, so now these two elements, element 1 and element 2, have been so connected together mechanically that only turning motion is possible between 1 and 2. Okay, so such a pair is called a self closed pair. You know that we do not use any force to keep these two elements in contact, right? Okay, on the other hand, what happens in case of force closed pair? Okay, in force closed pair, the two elements are not connected mechanically together, but the contact between them is ensured with the help of some force which is acting on these elements and forcing them to be in touch with each other. If they are in contact, then only they can transmit the motion, okay, from one link to another link. Okay, so what is the example of force closed pair? Is your cam and follower. Yes. Examples I will tell you, cam and follower. Okay, so say, see, it is the cam and follower. Okay, is there any mechanical connection between follower and cam? There is no any
No,
connection.
sir.
Right? So just follower is resting. See, this follower is resting on the cam surface here, and the contact between these two, that is between follower and cam, is ensured with the help of weight of the follower. So this weight will be acting, the knife edge follower has some weight, it will be acting downward, and that force will keep these two things in together, in contact. Okay, so then this cam will rotate like this cam will rotate, then follower will reciprocate. Okay, and in some cases we also use the spring force, okay, in order to keep follower and cam in contact. Okay, so I will tell you how the spring is provided. So suppose here is some stationary surface, fixed surface, okay, and here one spring is provided like this. So what this spring does, it always exerts a force on the follower. Because of that, what happens, that follower remains in contact with the cam. Okay, so sometime spring is used to keep these two elements in contact. Okay, if they are in contact, then only they can serve the purpose of transmitting the motion from one element to another. Okay, so got it, what is a self closed pair and what is a force closed pair. Okay,
Yes, sir.
okay, so now next we will start the next slide. Okay, so now let us come to the another concept, that is the structure. Okay, so from the word itself, okay, you are knowing what is the structure. Okay, when the word structure comes, what idea gets generated in your mind? Okay, so for example, a railway bridge. Okay, a complete railway bridge which consists of many members. For example, I will show you like this kind of structure you might have seen. Okay, and it can be complex also. Okay, or otherwise a very simple structure. I will tell you, it is made up of different elements. Okay, just like in case of the kinematic pair, two elements are connected. Here also the two elements are connected to with each other. Okay, so for example, here I will add the element, and here also I will add the element. So what happens that it also have different parts. This, say it is one structure. Okay, say it is made up of metal bars, metal rods, okay, which are connected like this. Okay, so it is made up of different parts, and different parts of the structure does not have any relative motion, as it happens in case of kinematic pair, that there is some relative motion between two parts. Here it does not happen. Relative motion does not take place. Okay, so you see that whatever is the angle between these two elements, theta, this angle will never change because no motion is happening between the two elements. Okay, so such an assembly of resistant bodies, okay, which does not have relative motion between them, is called as structure. Okay, and structure is different from the mechanism, from the machine where motion between the elements take place. Okay, so what is the purpose of structure then? A structure has the purpose of carrying the load. If you keep some load on the structure, okay, it does not deform. Okay, it maintains its position or configuration. Okay, by straining action. Strain means what? Means some deformation will take place. That deformation will be negligible, right? Because all these are the resistant bodies. They will oppose the forces. They will not deform under the action of forces. Okay, so that is a difference between a structure and a mechanism. In mechanism, the links will move with respect to each other, but in structure they won't, and that's why we do not call the parts of the structure as kinematic link. Okay, what do we call them? We call them the members of the structure. Okay, so then I think I can move further. Any doubt?
No, sir.
Okay, so see, it is an example of structure, roof truss. Okay, like this. All these are the members of the structure, but there will not be any movement between these two members or between any of the two members. No movement will take place, and this structure will carry the load on it. Okay, okay. So load may be compressive, load may be tensile. So next, okay. So now let us come to the next topic, kinematic chain. Okay. So far, what we have learned, we have seen what is kinematic link. Okay. Then we have seen that when two kinematic links are connected together, they form a kinematic pair. Okay. Now let us extend this, okay, uh, to the to make it a kinematic chain. Okay, so how kinematic chain is done or is made? Kinematic pairs are coupled, okay, in such a way that the last link is joined to the first link. Okay, in this way you complete the loop, okay, to transmit definite motion, or definite motion we also call as completely or successfully constrained motion. It is called a kinematic chain. Okay, so how you will assume? See, okay, it is one kinematic link. It has two connections at its two ends. Okay, so I will connect one more link to it. It will make a kinematic pair. Okay, it is such that this one link can rotate, can turn, okay, with respect to this one. Then you can also join another link like this. Okay, and finally I will join the last link with the first link so that this loop is closed. Okay, so if I have to number, then first link, then it is second link, it is third, and it is fourth. Okay, so when last link is connected to the first link, then whatever is formed is called as kinematic chain. Okay, the difference is that between kinematic chain and structure, that in structure there is no relative motion possible between its members, but in kinematic chain you can see that these links have relative motion between them. So two can turn with respect to one as well as with respect to three, because when it will turn, the angle between these two will change, one and two, as well as the link 2 is also in contact with link 3. So this angle will also change. So there you can see the one kinematic pair is by link 1 and link 2. They make one kinematic pair. Then link 2 and link 3, they are also in contact. So they make another kinematic pair. Link 3 and link 4, again they are in contact. They make one kinematic pair. And link 4 and link 1 is again they are in contact with each other with relative motion possible between them, so it is also a kinematic pair. Okay, so such in such a way there are four kinematic pairs. Okay, and these four kinematic pairs are making one kinematic chain. Okay, so are you getting the definition of kinematic change? Okay, only you have to do what? You have to just keep connecting the one link with another link. Okay, and last link will be connected to the first link. So it makes a kinematic chain. Okay, so next let us see what is the condition, how you will check, okay, whether the given given assembly given assembly of the different parts is a kinematic chain or it is a structure or it is something else. How you will define? So there is this condition which you can check for the given assembly. Okay, so what is that condition? That in a kinematic chain, left hand side is equal to right hand side. In left hand side, what is there? L is what? L is number of links in a kinematic chain. So you have to count how many links are there. So for example here, okay, we have seen that how many links are there? 1 2 3 4. Okay, okay, otherwise one more criteria is there that you can use the equation 2. Okay, it is we are considering left hand side. Next, right hand side, what is there? 2p minus 4. So what is p there? P is the number of kinematic pairs. So how many pairs are there? Okay, so if you count the pair 1 will be 1 and 2, that will be one pair. 2 and 3, it is second pair. 3 and 4, it is third pair. And 1 and 4, it is fourth pair. Okay, so number of pairs are p. You can keep here 2 into 4 minus 4 means 8 minus 4, 4. And how many links are there? Links are L equal to 4. So 4 equal to 4 means whatever I have drawn here is a kinematic pair. Okay, you can use this equation to check whether an assembly which is given to you is a kinematic chain or not. Next is you can use the second equation. Okay, where L you are familiar with. Okay, but what is J? J here is the number of joints. Okay, so number of joints is nothing but, see here, joint is where two links are connected. Okay, and in such a way the joints also have the its types, like turning joint, which is called as pin joint. Here pin joint, then there could be sliding joint. So in sliding joint, what will happen? Sliding motion is possible because of that joint. Okay, for example, say it is the fixed surface. Okay, it is the fixed surface and you put a piston over here. So this piston can slide in this guide. So it is a sliding joint. Okay. So by counting the number of joints and number of links, you can use the second equation to decide whether the given thing is a kinematic chain or not. Okay. Are you getting this formula? L is equal to 2p minus 4. So you uh, get it clear that L is what, P is what. Okay, L is the number of links, P is your number of kinematic pairs. Okay, so for to form a kinematic pair, two links must have contact. Okay, for example, here link 1 and link 3, they are not having any contact between them, a direct contact, right? A direct contact. So I can't say that the link 1 and 3 forms a kinematic pair. No, it cannot be said. But 1 and 4 are making one kinematic pair because they are in contact at some point. Okay. So it is about the kinematic chain. You note down this formula. L is equal to 2p minus 4. Any doubt if you have, you can ask, or I will then move to the next slide. Okay. Have you noted it? L is equal to 2p minus 4. And what is L over there? What is P? Note it down. Okay. Should I move or wait?
So you can move on.
Yes. Also, request you to type your roll number, okay, in chat box. that will be considered as your attendance. Okay, so now let us apply the same formula, that L is equal to 2P minus 4, to decide whether the given assembly or arrangement, okay, is a kinematic chain or not. So see, these three links are connected with the help of pin joint like this. Okay, now let us decide how many links are there. There are three links, AB, AC and BC. So your L is equal to 3 number of links. Now number of pairs, say link 1 and 2, they are in contact with each other. So they make one pair, 1. Then link 2 and link 3, they form one pair. So 2 pairs. Then link 3 and link 1, they are also in contact at some point. So they form another pair. So in total there are 3 pairs. Okay. So now using this formula, L is equal to 2P minus 4. L is what? L is your 3 number of links. Now let us consider the right hand side. Right hand side is 2P minus 4. So number of pairs are 3. 2 into 3, 6 minus 4. So what is remaining is 2. So on left hand side there is 3 and right hand side there is 2. Okay. So this equation is not satisfied. Hence given is not a kinematic chain. It is not a kinematic chain. Okay. Motion is not possible between any two members. See, when you will try to rotate the link 1, okay, so what will happen, that link 1 cannot rotate with link 3, okay, or in another words, the angle between link and link 1 and link 3, it will always be constant. You cannot change it, you apply any force. Okay, similarly the angle between link 3 and link 2 will not change, because no link will rotate or will turn. Okay, and similarly if you want to slide one link with respect to another, it is also not possible, because this link 3 is connected here at A. Also the point C is connected at with link 2, so you cannot just slide it. Sliding is not at possible. They will just turn, but turning is also prevented. So it is called as structure or locked chain when left hand side is greater than right hand side. Okay. So in this way you can decide for any uh, arrangement. Okay. Next, again, if we run out of time, you have to join back immediately. Okay. I, again, consider this 4 links arrangement. It is link 1 AB, which is connected to link 2 BC, then link 3 CD, and then link AD, link 4. These 4 links are there. Let us check whether it is a kinematic chain, whether motion will be possible between its members. So again, use that formula. Your L is equal to 2P minus 4. Okay, formula, get it by heart. L, your L is equal to 2P 2P minus 4. So count the number of links. How many links are there?
4.
4 links. Now count. So your left hand side there is 4. Okay, on right hand side, you okay, on right hand side you count the number of kinematic pairs. Kinematic pairs you form. How many kinematic pairs will be formed here?
4.
4, correct. So here if I put 4 here in this formula, 2 into 4, 8 minus 4, 4. So on right hand side also I will get 4. So I can say left hand side is equal to right hand side. Means it is a kinematic chain. Okay. And this kinematic chain particular, okay, is called as constrained kinematic chain. Means one definite or desired motion will transmit through its link. The motion which is desired by the designer, which is expected from it, okay, it will not happen that you cannot predict the motion. Okay, suppose if I know that what is the angle between link AB and link AD, AB and AD is theta, then I can surely locate that where will be my point C. Okay, if I am knowing the length of these links, suppose I know the length of link CD and link CB, then I can easily locate the point C. Means I can predict the motion of the kinematic chain as well as path of its different point. So as I can to locate all the positions of different points or different links, I need only one variable. I need to be given only theta. Then I can easily decide the relative position of all other links. So I will say that this mechanism is having 1 degree of freedom. Okay, and in actual practice, because theta is only one variable, I am using only one variable to locate all other links. Okay, and the position or configuration of these links will change when theta will change. If this angle will change, accordingly these other two links will occupy the different position. Okay, so just here it is given that let's say that AD has rotated and point D has gone to D dash, then C dash will be coming here. Okay, and link CB will be like this. It will be the next position of the kinematic chain. Okay, so in uh, practical applications, the kinematic chain with 1 degree of freedom is very useful. Okay, or you can say constraint kinematic chain is useful. Then let us move to the next topic. Next case. See, you consider this arrangement of 5 links. You apply the same formula over here. L is equal to 2p minus 4. Okay. So here you will find that in this case, your left hand side is less than right hand side. So when left hand side is less than right hand side, then such a chain is known as unconstrained chain. Okay, you have not properly restricted it. Okay, and you cannot predict all the position of different links using a single variable. Okay, for example, suppose I know the length of each and every link, and I have been given that this angle between link 1 and link 5 is theta here. And if I ask you, suppose link 1 is here, link 5 is here. If I ask you to locate other 3 links, like link, where will be link 4? Where will be link 3? Where will be link 2? So I cannot find out, okay, because the information that is only the theta is not sufficient to help me in locating link 2, link 3 and link 4. Okay, so you will say that we want one more variable. Okay, suppose if you give me this angle also, the angle between link 1 and link 2, 5, then I can easily locate link 3 and link 4. So in this particular kinematic chain, I need two variables, theta and phi. Okay, means two inputs are required. So it is not a kinematic chain with 1 degree of freedom. It is a kinematic chain with 2 degrees of freedom. Okay, and that's why it is called as unconstrained kinematic chain. Okay, it is one case. Then uh, next case, let us consider. Let's see, it is also one case where 6 links are there, right? So if you see it properly, then you will see that A, B, E. It is only link 1, A to E. A to E is one link, and at one point on this link, that is at point B of the link AE, okay, this particular link is connected BC, and again at one point of the link BC, you see here the another link GF is connected. Okay, so you will not you should not face any difficulty in counting the number of links. Okay, so link 1 is AE. Okay, you can't say that AB and BE, these are two links. No, link ABE, you can say that it is one link, or you can say link AE is one link. Okay, or you can also say that link AB is one link. Okay, without saying B is another link. So link 1, then it is link 2, B to C, then link 3 is C to D, and D to A, link 4. Then here link 5, E to F, link 5, and F to G, link 6. Okay, so if you apply that formula, L is equal to 2P minus 4, so you will find in this particular case that left hand side comes equal to right hand side. So you will assert it that it is a kinematic chain, constrained kinematic chain. Okay, now here it is a chain which is having more than 4 links. Okay, so such a link is known as compound kinematic chain. If the number of links are greater than 4, it is called as compound kinematic chain. Okay, so getting this, any doubt in this?
No, sir.
Okay, so let us move then to the next topic. 54. Okay. So I think our session has been extended. It has not given us 10-minute warning. Okay, let us see. So up to this, we have seen the what is a kinematic chain. Okay, when different links are connected, so that last link is connected to the first link. Okay, it forms a kinematic chain. And in order to check whether a given arrangement of links is a kinematic chain, there is one equation, L is equal to 2P minus 4. And depending on different situation, whether left hand side is equal or less than